liftoff of the mighty Delta IV Heavy rocket.
In August 2018 in Cape Canaveral, Florida, NASA launched Parker Solar Probe to touch the sun. After spending a few years spiraling closer to our star, the spacecraft has finally arrived.
It's amazing. Parker Solar Probe is touching the sun.
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
This is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the sun? To answer that, we need to look at the sun's structure. Unlike Earth, the sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the sun and gushes out into space as solar wind. The boundary that marks the edge of the sun's atmosphere is known as the Alphane critical surface. We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the sun's atmosphere during eclipses because it's important for understanding how our star influences life in the solar system. But much about the corona remains a mystery.
Two of the most challenging scientific mysteries in astrophysics occur in a region that we call solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere, the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the sun, the spacecraft was around 20 solar radii, or 8 million miles from the sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took these images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. Here we see distinct cells. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life, so understanding it is critical as we search for life beyond our solar system.
that will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.